Welcome back to the Virtual Elephant YouTube channel. I'm Chris Muchler, Principal Enterprise Architect and VCDX 257. In this video, part 9 of my VCF Home Lab series, I'm going to show you how to install the NSX Advanced Load Balancer through the SDDC Manager. Now, the NSX Advanced Load Balancer, or AAVI, can be leveraged for both VM-based and Kubernetes-based workloads. So let's get started. So jumping in right where we left off in part 8, where we had installed the VKS supervisor cluster, we now want to install the NSX Advanced Load Balancer so that we can begin to leverage it within the environment. So you can see here on the screen that I have a window open to my SDDC Manager. We're going to log into it, our vCenter server, and our NSX managers to be able to show how the workflow to deploy the NSX Advanced Load Balancer works within the SDDC or VCF environment. All right, so as we take a look here in the environment, here's our NSX manager. You can see that I've actually deployed quite a few things at this point within the lab environment as I've been using it over the last couple of weeks. So you can see that we have our tier 0, which is an active ECMP tier 0. You can see we have our primary tier 1 that's acting in a distributed mode. And then we have two tier 1s that VKS has created for us, one for the supervisor cluster and one for the workload clusters that we're going to be deploying. And then you can see here under our primary tier 1 that I have a number of segments that I've created, and I'm running around 47 virtual machines within it right now. And now if we come over here to our vCenter server view, you can see here that we do have an error. I've got a CMOS battery that's dying in one of the servers that I need to get sorted out. So we'll go ahead and acknowledge it for right now. You can see we are running everything. We're using a little bit more than 50%, 59% of our memory within the environment already. Everything looks good from a vSAN health and a DRS score. We want to make sure that everything's healthy within the environment before we go ahead and run these NSX or these SDDC Manager workflows. So looking at our SDDC Manager here, again, similar view for the dashboard now that you're used to seeing within vCenter server. Now, one of the things I haven't shown you on screen, but I have done already, is in the SDDC Manager, under the lifecycle management, I've actually connected here on the depot settings, I've connected my account to be able to download bundles, and I've already downloaded a number of bundles. And I'm going to show you how to do more of this lifecycle management in the last video, part 10 of the VCF Home Lab series. So I'm not going to go over a lot of that right now, but I have already downloaded the bundles for the NSX Advanced Load Balancer. So we're just going to come over here to workload domain. We're going to click on our management cluster, consolidated VCF, what have you here. And we're going to come under here to actions, and we're going to go to deploy NSX Advanced Load Balancer. Now here you can see on the screen, it has a select version. If you haven't downloaded anything yet, this is going to be blank. When you do the drop down, you can see here that I've actually installed two different versions, 22.16, 22.17. Both are compatible with VCF 5.2.1, so you'd be fine to use either of them if you wanted to practice doing an LCM upgrade with the NSX Advanced Load Balancer. And to see how that works, you could certainly deploy 22.16 and then upgrade to 22.17. But we're going to just go ahead and click 22.17. This one was released last year. So once we do that, it's going to ask us for the form factor that we want to deploy the controllers within. and we're going to go ahead and say medium, and it's going to show you here a little bit about what's available and what's going to be consumed within your management cluster that you're deploying this. Now we're going to go ahead here, select an admin password, and then we are going to give it 3 IP addresses for the controllers themselves. I'm going to come over here in another window real quick and just log into my Pi-hole so that I can make sure that I've got the right IP addresses, just to make sure. Let's search here for Avi. So we're going to put these again on our management, VM management VLAN, which was VLAN 210. So the first one is going to be 29, second one is going to be 30, and the final one is going to be, oh wait, no, hang on, that's wrong. 29 is actually going to be our VIP. So we're going to start the nodes themselves off at 30, 31, and 32. And then here, our cluster VIP is going to be 29. Our fully qualified domain name for it is going to be Avi home virtualelephant.com. And our cluster name is going to be VE Lab 01 is what we'll call the cluster for Avi. We'll go ahead and hit next. We can see that it's going to review the selections that we've made, and then we're going to go ahead here and click on Start Deployment. Now this Avi workflow inside of the SDDC Manager is actually going to do the deployment of the Avi controllers. Okay, so we'll bring this up. We can see it starting to perform some validations for it, and it's actually going to tie it into our NSX Manager. So as I switch views over here, we come down here to Fabric, or actually, sorry, under Configuration, System Configuration, and then Appliances. And once this stops spinning after it looks for the status, so we can see here are our NSX managers, and the SDDC Manager is actually going to integrate them into our NSX-T managers here, and we will see the NSX Advanced Load Balancer controllers, or Avi controllers, actually start showing up here inside of this UI as the deployment goes on. So again, depending on your hardware and everything, this deployment can take anywhere from 20 minutes to an hour, depending on what you're working with. I expect this will probably take about 30 minutes within my environment. We'll start to see some of the appliances actually be deployed inside of our vCenter server, as well as the tasks here on the SDDC Manager. And then, like I said, we'll also see things start to appear within our NSX Manager. So I'm going to switch to a type of split screen where I'm going to show the SDDC Manager on one side, and then I'll actually show the NSX Manager on the other side of the screen while this runs. And again, we're just going to let this run to completion. Once it's done, then we're going to have to log into the controller. It's the controllers themselves, log into one of them because of the cluster IP. We'll log into one of the controllers, and we'll actually do some finalization steps to make sure that everything is connected correctly. We'll actually deploy a dummy virtual service, and that will help us make sure that our networks that we're going to be using for our Avi VIP, if you remember, we actually created a segment earlier on in our NSX-T domain to be able to have a segment specifically for the Avi VIPs. So we'll make sure that that pool of addresses is accessible within the Avi controllers, that we can then deploy a dummy virtual service to make sure that everything is working from an Avi perspective from start to finish before we turn this off and finish up the video. That way we know that everything from an Avi perspective is working. We've got it fully configured within our environment. So let me switch up the screens real quick, and then we're going to go ahead and just let this run. Our ALB workflow through the SDDC Manager has completed. Now, if you were following along in the recording, you might have noticed that it actually restarted 2 different times and was finally successful on the 3rd. The interesting thing about that is that actually the workflow itself restarted it after it determined that there was some sort of issue within the appliances that it went and deployed. So let me first maximize this, the NSX window, and I'll make this a little bit bigger again. I had reduced it during the recording to try and make it a little bit more visible of what was going on. So you can see here that we have our NSX Advanced Load Balancer. The cluster is reporting as stable. We can see our virtual IP 10.210.0.29, and we can see our 3 appliances are online and that they are all running 22.1.7 with their respective IP addresses. So the next thing that we want to do is actually log into the ALB interface, the management or control plane interface, and actually complete the configuration of the environment. So we're going to go ahead here and open up another window. We're going to go to https alb.home. And you can see here it has something saved from before. I'm going to go ahead and clear that out. So we're going to get our SSL warning because I'm not doing certificates right now. And now here you should be able to do username admin and then the password that you specified as part of the deployment within the SDDC Manager. So we'll go ahead and do that here. We can update it. So here we see that it pre-popped a passphrase. We can type something in here to finish setting up the cloud. So we're going to go ahead and type that. You can see that we see our 2 DNS resolvers, 10.1.10.11 and 10.1.10.12. Those are our pie holes. We're going to go ahead and tell it that our DNS search domain should include home.virtualelephant.com. We'll hit next. We're going to use localhost for sending sending emails out. So we'll make sure that this is reflective of our FQDN, avi.home.virtualelephant.com. Hit next. We can go ahead and say that we're going to do this as the standard way, and we'll click save. So this is the initial cloud configuration. And so it's going to pop right here that we don't have any sort of virtual services within our applications. But what we want to do is come over here to infrastructure. We want to look at clouds. We can see here that the default cloud right now is in a system configuration, is in process. So this is going to potentially take a couple minutes to run, but we'll go ahead and let it do that. Meanwhile, we'll look here at the cloud resources and we'll come down here and we'll take a look at the service engine group. Now this is going to define how the service engines, or what actually act as the load balancer virtual machines within the NSX Advanced Load Balancer. So we can see here it has a default group. We don't have any service engines obviously deployed. We can see that currently it's limited to 10, a maximum of 10 service engines. We can modify that. We can see the number of virtual services, the maximum number of virtual services that can exist on each service engine is 10. So potentially 10 times 10 is 100 virtual services. And then we can see our HA mode is in the N+M buffer state. So we're going to click here on the little pencil to edit this. Okay, so we can do things like enabling real-time metrics. That is one of the things that really sets ALB apart in and of itself, especially when you compare it to the native NSX-T load balancer that's existed for quite a while. The real-time metrics and the troubleshooting capabilities within ALB are pretty spectacular. So you can see here we have our options for high availability mode. I will let you know that active standby, that's likely something that's going to go away in the near future. Generally, your 2 choices are active, and N+M. And then you can set along here some additional things. So number of service engines that we want to have, the buffer service engine, so essentially like a hot spare of 1. You can see we can enable self-election, we can enable CPU socket affinity, and we can enable dedicated dispatcher CPU. Really don't need to do any of these things unless we're running some very high performance applications. we can see here the number of virtual services that we want to run on an individual service engine. So one of the things that Avi is very efficient at is running far more load balancers or virtual services within the environment. There's all sorts of detailed documentation on where the limiting factors are for the amount of service engines, whether you're doing L4, L7, SSL, and so on and so forth. So for our environment, I'm going to really crank this up. I'm going to say, and this is still being rather conservative, but I'm going to say that there can exist 100 virtual services on each service engine itself. And then we're going to do compact or distributed. Distributed means have some number of SEs that exist and then deploy these service engines across them. Or compact means I'm going to actually just continue to deploy the service engines to a single pair of SEs until I reach that maximum that I've set above here at 100. So we're going to say scale virtual service, maximum number of active service engines for the virtual service. We want there to always be at least 1 up to 4. You can change this so that it's at least running on 2, for example, and a maximum of 4. This really just means that I'm going to have at least 2 service engines that get deployed so that all of my virtual services can be in compliance with this policy that I'm setting here. We're fine for using hyperthreading. I don't need to worry about geolocation. Not really worried about the security or the logging information here at all right now. So we're going to go ahead and we're going to save this. So we'll let that save. While that's saving, we'll come back here. We can now see that the status on our cloud is green. So everything looks like it's been configured. So we're going to come over here to Service Engine. We can see that there are none. We're going to look at the networks. It doesn't see any networks just yet. So what we want to do is come over here to Administration. We want to come down to System Resources. We're going to check some things here. So I haven't hooked up authentication or LDAP anywhere within the environment. That's one of the things that I would still like to do as part of my home lab. We can see it does have our DNS. It's got our NTP servers. Again, these are those same 2 NTP servers that the SDDC Manager has used throughout the deployment of all of the virtual machines, and it got that from our workbook. So all of this looks good. We're going to come down here to controllers. We'll look at the nodes. So it's showing us that our lab, VE Lab 01 controller clusters up and active. We've got our cluster IP and we see green. You can also see which of the 3 controller nodes is actually the leader. So it's 10.2.10.0.30, or basically the first one that we went and deployed. And I have a typo here, and that is probably why I was having a problem when I deployed these, because that should be 32. And I better check to see if there's anything that is trampling on top of. I didn't catch that when we were doing the checks. So let's see, 10 to 10.0.22. Oh, I'm fortunate in that nothing is trampling that. Oh, we're very lucky. Okay, let's see what's here. So our vCenter was 21, and then I didn't start anything until 25. I'm very lucky here that I didn't just totally blow everything up. So what we're going to do is we're going to trash this Avi 03. We're going to go 10 ones to fix it. And we're going to come do that on our other Pi-hole DNS server. So this is why you've got to be super careful, double check. And you can see even when I thought I double checked it, I still ended up making a mistake. So we'll delete that one. Very lucky. Okay, so that is actually probably why the workflow failed. I don't know. Okay, so that's, wow, we are lucky. Okay. All right, let's come over here. System settings, we're good there. Okay, so come back to clouds. We're going to edit our default cloud now. Okay, so it doesn't have an orchestrator. Okay, so this is where you have a choice to do how you're going to do some of this. And actually what we're going to do, because this is in through NSX-T, we're going to hit cancel. We're going to create an NSX-T cloud. And we'll call this VE-NSX-T cloud. So this is something that I thought the workflow would have done for us. Let's just double check that the workflow says it's truly done. Come back here to our SDDC Manager. Clusters. Okay, it does look like it's good. Okay. I don't see anything running in here. It says it's released all the locks and everything. Okay, so we're going to trust that this is done, but it didn't configure an NSX-T cloud for us, which I'm actually kind of surprised by. Okay, so we're going to tell it VE-NSX-T-cloud for the name. We're not going to do DHCP. We are going to give it the, it's going to be NSX home virtual elephant.com. We're going to have to create some creds. Okay, so it looks like it actually did that for us. Created a service account. Okay, so we'll try and connect. We'll see if this works or if I have to create some new creds. Okay, the transport zone is going to be our overlay network. Our logical router, again, this is going to be our primary one. And our overlay segment is going to be our AVI VIPs. Yep. Our data, that's for our, oh, this is for our management network. Yeah, we'll pull the addresses out of the AVI VIPs as well. So our data network is going to be the same overlay. And then we're going to just have one logical router and one segment that it's going to pull from. We're going to add our vCenter server. So this is vCenter-VCF01. I'm going to create the creds. And it created for us. And then the content library that we're going to use is the one that we've already set up, VE content-library. We'll click done. Okay, so coming out our management network, it's going to be on our overlay. It's going to use our tier 1. It's going to use the AVI VIP segment for our data networks. It's on the overlay. We only added the one logical router and the one set of VIPs. We have our vCenter server. Okay, and now for our DNS and iPAM, we don't have this set up, so we're going to create that now. So we're going to create this. We'll just call it VE-lab-IPAM profile. We can use this. Okay, you can see you've got a number. So if you do have Infoblox, iPAM, or something else that you're using, you can leverage that. I'm going to select our cloud. Can't yet because we haven't actually created it, so we'll hit save. Scroll down. So now it's selected that. Now we got to create a DNS profile. Call this the DNS profile. Okay, we'll hit save. vCenters, DNS profiles, and our resolvers. It's already got that, so we'll hit save here. So we'll give it home virtual elephant. NSX-T Cloud is DNS provider of type internal with no domains. There we go. So I wanted us to specify the resolvers even though it already has the DNS information in it. We can see that it's in a configuring state, so we'll give that a moment. We come down here, we can look at networks and see if it's added it. So now when we do this, we have to select our, we see that there's no configured or discovered subnets just yet. So give that a minute. Let's come over here. So we are green now on our NSX-T Cloud. Again, we see these are plugged in here. Go back here to networking. You can look at our topology. So we've plumbed it into this tier 1, and we've told it to use this segment 10511/24. So now we'll come back here to networks. We'll switch over to our NSX-T Cloud. We're going to edit the VIPs. Add a subnet 10.5.1. We're going to use static addresses for the VIPs and the SEs. So we'll do 10.5. So that'll give us 75, or that'll give us 25. So let's actually increase this. Let's go actually do 100. We're really not doing anything on this network. So we'll go 10 for 119, whoops, should give us 100. So we'll hit save. And then for this one, attached to the specific, I'm gonna add, and then we're gonna add, this time we're gonna go 10.5.1.120, 10.5.1.2, 29. That should give it 100 as well. And by splitting up the /24 when things are happening, then I can actually tell which one of these two network profiles it's actually pulled off. So it's showing us that it has 110. My math was wrong. And this one should pop up here in a minute. Let's look. Oh, do that. Let's see. 10.5.1.120 to 10.5.1.1019. Oh, for use for the VNix. Here we go. Now let's see, it's got a static pool. This one we told it to use for both the SEs and for the service engines themselves. So I'm going to come back here to clouds. I want to edit this. So the ALB prefix name, this is what it's going to append or prepend for the names of all of the objects that it deploys. All right, so we're good there. All right, so now that we have everything configured from a cloud perspective, what we want to do next is actually come over here to templates, policies. Here's the iPAM. iPAM profiles here. We want to edit this to tell it that we're going to use the NSX-T cloud name and that this network is available to it, both of those networks. So we will save. We'll look at the DNS profile real quick. We're good there. All right, so now the DNS profile is associated, or the IPAM profile is associated with the NSX-T cloud object that we created a few minutes ago. So now we're going to come over here to our applications. We're going to manually create a dummy virtual service VIP. And what we're doing is, by doing this and creating a dummy virtual service, it'll actually trigger the deployment of the SEs. So right now we don't have any SEs. And the one thing that you've got to remember is that when you're deploying SEs, the first time that you're deploying a virtual service and you don't have any SEs, then it's going to take a little bit longer because it has to spin up the service engine VMs first before it can then provision the virtual service itself. So by doing it this way, we actually kind of like circumvent that process later. So we'll create this dummy virtual service. It'll spit out a couple service engines, configure this thing on it for us, and then now those service engines are available for when we want to go and do a regular like workload that we're going to be deploying. So you can see here it grabbed a VIP for us, 10.5.1.10. Okay, but you can see that there's no virtual services associated with it yet because we haven't created one. So we're going to go and do that next. We're going to come over here to virtual services. We're going to create just a very basic virtual service. We're going to tell it in our NSX-T cloud, hit next. Our context is going to be our tier 1. All right, and then we're going to come here and we're going to give it a name. Well, yeah, we'll just call it that. Dummy Nginx virtual service, port 80. Our VIP, we're going to tell it to use the VIP we just created. We don't have any servers yet because I don't have any VMs that are going to be used by it. So we won't be creating a pool, but we don't need that pool in order for the service engines to get deployed. So come back here. So this is the service engine virtual service. All right, so you can see that it's been created, but it's not yet anywhere. So come over here, it shows red. If we look at it, it says it's waiting for image creation to happen. Let me open up my, and what we should see here is now it's actually uploading the AVI service engine OVA template up into the content library that we specified when we set up the cloud. Because again, we have to do all of this first time. So creating this dummy virtual service really kind of ties everything together for you so that when you're ready to actually operationalize this, all of these pieces are in place and the very first deployments don't take longer. Especially if you're doing things through like VRA or some sort of other automation for your deployment or load balancer as a service. By pre-plumbing all of this stuff, you don't have to worry about there being unexpected timeouts in your other processes. So we're going to go ahead and let this upload it. We'll watch it. And then once it's done, we should actually see it start to deploy those first set of service engines. Again, we specified that there need to be 2. So it should deploy at least 2 for us and then provision that dummy Nginx virtual service onto it. Now it'll stay red because there are no virtual machines that are attached to it yet. But this at least tells us that everything is pre-plumbed and we should be good to go with our actual virtual machine deployments for load balancers. All right, so our ALB service engines have been deployed. And if you noticed, one of the things that I had to do on the screen was I actually had to sort out the license and set it to the ALB Advanced Load Balancer Enterprise and not the Enterprise with the cloud. So that's one of the things I guess that we need to change after the SDDC Manager workflow goes. And then once we did that and we specified the same information in the cloud account, so I'll show you here in the service engine group. Before we were editing the default cloud, but now that we have this NSX-T cloud, we also have a default group here. And so I came in here and actually edited the same things, right? So N plus M with the buffer, maximum of 10 service engines with one buffer. I did 100 virtual services per service engine, compact with at least 2, a maximum of 4 for each virtual service. Gave it the prefix name. I gave it 4 vCPUs, 8 gigs of memory, and I reserved both CPU and memory for these, as well as turned on hyperthreading and increased the disk space that requires you to do so when you do 4 and 8 from 15 to 21 gigs. And then obviously we added the vCenter server. Once we did that, that allowed us to actually deploy the service engine as we would expect. And so it went and automatically did that for us, and that's what we just watched finishing happen on the thing here. So it looks like everything is up from a service engine perspective. So we've got everything plumbed correctly. So now we can start using the NSX Advanced Load Balancer however we see fit, whether it be for virtual machine workloads or for Kubernetes. And with things like VKS or vSphere Kubernetes service, we can tie it in there. OpenShift from Red Hat also has an AKO operator, which you can run inside of your OpenShift environments to be able to create dynamic load balancers on the fly as ingress controllers inside of your Kubernetes cluster running in Red Hat OpenShift. And so you have a myriad of opportunities for you to be able to leverage the NSX Advanced Load Balancer across different Kubernetes platforms. So in the final part 10, we're going to show you how to do a lifecycle activity. We're going to upgrade this VCF environment from 5.2.1 to 5.2.1.1, and we're going to apply some patches to the SDDC Manager as well as some of the other components within our vSphere environment. So as always, if you're enjoying this content, please make sure that you subscribe to my channel, turn on notifications, and hit that like button. And leave me a comment below and let me know what you've thought of this VCF Home Lab series. As always, feel free to reach out to me on Twitter or X @Chris Mutchler, and I look forward to talking to you next time.